Hello students, this is the video number 43, Chapter 9, Current, Electricity, Part B. In that we will discuss potential difference and resistance. Class 9 for subject physics. Potential difference is the ratio of work done upon charge. So potential is defined as the work done in bringing the Q charge from infinity to that particular point. So work done will represent by W and charge with Q. SI unit of potential difference or potential at a point that is measured in volt. Work done in joule and charge in coulomb. These all are the SI unit of these quantities. To define 1 volt, will take joule also unity and coulomb also unity. So suppose these are the two conductors A and B joined with this wire, and if charge 1 coulomb I want to transfer from A to B, then how much work is being done or required? That is 1 joule. It means potential difference between these 2 points is, between these 2 conductors is 1 volt. After that, the flow of electrons between the conductors. Flow of electrons between the conductors. Suppose there is one positively charged body, that conductor is connected with this wire and it is connected with B conductor which is having negative charge. Positively charged body A means this A body is having deficiency of electrons and B body is having already negative charge, means it is having excess of electrons. So electrons flow will take place from high concentration of electrons towards low concentration of electrons, means from B to A. And conventional current, conventional flow of the current will be opposite to the flow of electrons. It will be from A to B. In this second one, A body which is positively charged is connected with the uncharged B body. So the flow of electrons will take place again from B to A. Why? Because A body is having already deficiency of the electrons, but uncharged body is having more electrons, because here the number of protons and number of electrons are equal. But if we compare the negative charge, so electrons will flow from B to A and conventional current will take place in opposite direction. That is the flow of positive charge from A to B. Come to this third case, when the negatively charged body, that is A, is connected with the B which is again uncharged. So in this case, high concentration of electron is with this A body and the electrons flow will take place from A to B and conventional current will take place from B to A. So that will be opposite to the direction of the flow of electrons. Next is direction of the flow of current which is conventional current, and flow of electrons. So just to bring the uniformity in the basic rules of the nature, the body falls from height or high gravitational potential towards low gravitational potential. Suppose this is the ground. So this particular ball, when it is allowed to fall from a particular height, okay, so that particular ball will come down only. So height will also matter. Body will move automatically from high gravitational potential towards low gravitational potential. Second, water always flows from high pressure to low pressure. Third one, when the two bodies at different temperature, they are coming in contact with each other. This is B body. Now A body temperature is lower than B body. So heat flows from B to A. That is from high temperature towards low temperature. So there is one common thing which we'll observe, like body moves from high to low. Here also the water is flowing from high pressure to low pressure. And third one, heat also flows from high to low temperature. It means, just to bring the uniformity in all the rules, positive charge flow also assumed to be moved from high potential to low potential. Means positively charged body towards negatively charged body. Now if positively charged body is connected to the negatively charged body, so this plus Q charge will be repelled by this positive charge and will be attracted towards negative charge. So direction of the conventional flow of current will also be from positive to negative, and electrons will flow in opposite direction. Why? Because electrons are negatively charged particles and they will move from negatively charged body towards positively charged body. Negative they will repel, and positive is there to attract all the electrons. So electrons flow will constitute electronic current, and the flow of positive charge will constitute the conventional current. Next is electrical resistance. The meaning of this term is, resistance is a kind of opposition offered by the material to the flow of current. So by taking this magnified view of the wire, I'll try to explain the concept of the resistance. Here is the magnified view of the wire. Let it be a B wire, and it is connected with the cell to this simple circuit. This is the positive anode of the cell and this is the negative cathode of the cell. Here is the key. When it is switched on from here, so positive potential will come to this A end and B end will become at negative potential. So here inside this certain atoms and ions position is there, which are the kind of obstruction for the flow of electrons. So electrons position I am going to represent with this dot. In this way, these electrons, because of their negative charge, will be repelled by this negative charge and will be attracted towards positive charge. But on the bulk, these all electrons can't reach over here because of the presence of these ions. So they will strike with these ions and will lose their kinetic energy. Their motion will get slow. But still this negative potential is there to boost up the electrons, and these electrons will drift from B end towards A end. That's why, so the material which will offer certain obstruction to the flow of current, so that is called resistance. SI unit of resistance is ohm, and it is denoted by this symbol omega. Then there is another important law, that is Ohm's law. According to Ohm's law, current is directly proportional to V, that is voltage. And similarly, I can write V is directly proportional to current. Means high will be the voltage, higher will be the current. One single cell will give you less current, but more voltage. Suppose of 4-cell battery will give you heavy current. And this directly proportional sign, if you replace with equal to sign, one constant of proportionality, that is R. This is called constant of proportionality. Okay, the name is resistance. This is the resistance. So here is the expression of the Ohm's law. From there I can get two more expression by rearranging it. I is equal to V upon R and R is equal to V upon I. Okay. Now from here, if I want to define 1 ohm, so SI unit of resistance is 1 ohm, SI unit of voltage is volt, SI unit of current is ampere. So from this expression, easily I can get the definition of 1 ohm. Come back to the same circuit. Suppose I want to define 1 ohm. It means if 1 volt voltage I will apply across the two ends of this wire, and suppose how much current is start flowing through this wire, that is 1 ampere. It means how much resistance will be offered by this AB conductor to the circuit, that is 1 ohm. So 1 ohm can be defined as the resistance of a conductor if a current of 1 ampere flows through it when the potential difference across its ends, that is A and B, is 1 volt. Okay. After that, very important part, that is the last concept of the B part of current electricity, that is factors affecting the resistance of a conductor. Factors affecting the resistance of a conductor. So first one is length of the wire. Length of the conductor or wire. Resistance is directly proportional to the length. If less will be the length, number of collisions will be very small in that wire. If length will be large, number of collision of electrons with the ions will be large. So resistance will increase with the increase in length or decrease with the decrease in length. Second one, that is area of cross section. So resistance is inversely proportional to area. Means if resistance will consider with the high area or the thickness of the wire, if it is more, resistance will be small, and vice versa. Means area if it is less, resistance will be high. So thicker wire whose area is more, resistance will also be less, and thin wire whose area is less, resistance will be high. Come to the third point, temperature. So with the increase in temperature, the vibrations of these ions will be very large, or means number of collisions of electrons with these ions will also be increased. On the basis of that, if the number of collisions will increase, resistance will automatically increase. So simply you can say resistance is directly proportional to temperature. Fourth one is nature of material. So some of the materials, they are conductors, and some of the materials are insulators. So conductors are those materials who will allow the current to pass through themselves. Insulators are those materials which will not allow the current to pass. So conductors generally will have less number of value for the resistance, and insulators will have high resistance. Why they will have less resistance, conductors? Because of the presence of free electrons, and insulators will have negligible or very less, negligible number of free electrons. So due to the presence of free electrons, conductors will offer very less resistance and insulators will offer very high resistance. So these are the four factors. You can revise and read it properly from the book, and you can watch the video again and again to get command on the topic. So with this, your chapter is over, and in next video I will explain the last chapter, that is related to the magnetism. Thank you very much.